Hello, 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 hello. Oh, 23. Woo! Hello, everybody. Welcome to the last official daily YouTube live stream of Guillotined Chemistry. The great experiment, the 2 wild weeks of the early remote learning. Again, I'll explain sort of how we got here and where we'll be going from here. Very proud of what we've done for 2 weeks here, but let's again quickly update what's going on. I also have some updates for my own students in terms of assignments and things like that. Oh, look at all these people. Hello, who we got here? Man, we start off with Adam, Clayton, always a good time. Maddie, Madison, hello, Sharon, Emily, hello, more alumni, hello, Lucy. Rachel's here, hello, Alex, hello, Emily, Lindy, hello. Alex, hello. Alex, you better be working on some more animations. Hunter, hello. Derek, hello. Yeah, so remember, let's talk about what happened here. Remember, it feels like a long time ago, but the district was, again, I think wisely said at the beginning, listen, use whatever you're comfortable with. Let's just get instruction out to students. But no live cameras, no looking in their house, no you looking in your house and stuff. And that was totally understandable. And so I created, or actually I kind of dusted off. Oh, I know. Well, hold Joe, you, did you just showed up, Joe? Hello, Joe. Hello, Isabella. Hello. Yeah, Joe, you hadn't showed up in the chat yet. Hello. And I said hi to you too. There is a latency issue here. It's the internet. So anyway, so that's why I dusted off this little avatar here that you might have seen from some of my earlier videos. And so that way I could give you guys some semblance of live instruction without having to worry about any live video. So using this guy and using YouTube live seemed to be like the best option for those early Wild West weeks of remote learning. And again, I've seen this from both sides. I've seen this from the teacher side and the parent side now, since I have 2 kids at McKnight. And I think, and I agree that I think we needed some consolidation of resources and platforms because people were going a little insane with all the different things going on. And I think it sounds like the district, and I'll learn more about this tomorrow in our in-service, it sounds like the district has worked out the legal issues of using live instruction. And so really, I guess I, as Avatar Anacle, Papa Anacle here, there's just really no need to have a animated avatar of me anymore if I can just start live streaming. And then I think one of the things they don't want us doing is obviously recording those live lectures. Now, I don't know how that's going to affect students that cannot show up at those office hours. Again, we'll try to learn more about that tomorrow. So that's where we are. And so, as much as I've enjoyed this, and I've really enjoyed the technical challenges of working with YouTube Live, and we're learning about OBS and fixing up my character animator skills and learning about PowerPoint. The new PowerPoint is actually pretty nice. So I've learned a lot of great skills. I hope you guys are picking up new skills too. And so we'll just continue that into the next phase of things. Probably, again, I'm going to be either using Google Meet or Blackboard Collaborate. I think those seem like the best for kind of what we're doing. Blackboard Collaborate has more bells and whistles. I'm not sure I want those, but I'll check them out. If you have any preferences based on your other classes, please let me know in the chat which you'd rather see me use, and I'll take that into account for next week. But that does mean, again, that's going to be a sheltered content. And so if you are an alumni or somebody else, you unfortunately will not have access to these lessons anymore. But do not despair. I've been setting up a studio in my basement here to do some recording, and I think based on I've really enjoyed going back and revisiting modern atomic theory, and so I've kind of planned out a pretty epic new content stream of just kind of going back and revisiting modern atomic theory with the knowledge of 5 more years of teaching it. And that should take me quite a while just to work through those. And I may or may not be trying to get some collabs going with some people that are more famous than I am on YouTube. So I am going to start producing more content. And we might still do these live streams. Anyway, hello, Joe. Yes, Joe. Hello, Joe. It's good to see you, buddy. And so anyway, so that's the idea of that. I understand the frustration. Again, listen, and I'm sure the administrators would like your feedback. Again, for the record, I completely understand why the district's doing this. I think there's going to be costs and benefits of whatever way we're doing remote instruction. But I've enjoyed these 2 weeks. I think this has been a lot of fun for me. And so anyway, so now some other questions for the good of the order. There was some confusion about some of the video quizzes. I've gone in and I cleaned that up. The confusion is after spring break, there's a couple video quizzes that cover 2 videos, and then the names of the videos don't match up with the names of the video quizzes. Yeah, you know what? I have, yes. There has been a demand for guillotine chemistry TikTok. I don't have any of my chemicals though. Maybe we'll see. I might do a kid. I've told that's where the kids are hanging out now, TikTok. So if you check it out, if you check out the Blackboard calendar now, I think you'll see that it's a little bit more clear. It's called like it's called like modern atomic theory or modern atomic history. Periodic ramifications, I think, is what I call periodic table lengths. And so anyway, so what I've done is I've moved the quizzes around so that it covers, it's due on the second day of 2 video content. This is the time of the year that I started breaking up some of my videos based on content, not over what's covered in a classroom. So if you just check out the videos, I think you know, even though the names might not make sense, it'll match up with the notes pretty quickly. So anyway, so take a look at that. I think I cleared that up for my current students on both Blackboard Calendar and Pearson. So I shifted a couple dates around. There are a couple people asking about the MCs. Remember that the cumulative review MCs were optional. The next one is still optional. But again, since this is going to be a lean fourth quarter, they will be mandatory after the next one. And if you look on the calendar, I think I say mandatory and optional. So Grace has that figured out, though, if Grace is out there watching. Anyway, and so I'm very excited to let you know, I'm still looking at your STOIC assessments. They're doing fine. I'll try to get those graded over spring break. Woo, spring break. But I will be posting information about your next kind of individualized creative assessment. It'll be on modern atomic theory. Essentially what you are going to be doing is picking out some aspect of modern atomic theory that you like, anywhere from like a timeline to a deep dive about a theory or a person. I'll list a lot of examples. And you are going to be creating a 2 to 3 minute video about that with the idea of you're going to be in that video covering at least 5 content ideas as an expert and creatively. And so I will have a rubric for that based on what we've learned about video rubrics from electrolysis and things like that. So I'm very excited about that. I'm going to make it really open-ended, and then you'll get out of it what you want to get out of it. There's even an option for collaboration, remote collaboration with somebody else if you'd like to, which is going to be a little trickier. But I think if you want to collaborate with somebody, I think that would be pretty cool too. Cole asked a good question. Can you teach us how to make an avatar? Maybe I'll show you. Guys all have access. Remember, this guy that I'm using is based on Character Animator, which you guys have access to, right? I even did a workshop on that on Tech Day or whatever before the holiday break. So if you want to learn more about Character Animator, again, you have access to the program for free. Each one of you in the North Allegheny School District is getting access to like 10K of software a year from Adobe. But whatever I teach you, there's a guy named Dave Warner who works for Adobe Character Creator, and he goes by the handle OK Samurai. And everything I've learned about Character Animator, I've learned from him. In fact, even some of the things on me, so like even a lot of these things, I've just ripped off some of his free puppets, like the mouth and things like that. So yes, maybe I'll do that. Maybe I'll show you how to make a Character Animator puppet. But again, there are better people than I. Dave Warner, big shout out to him. He's wonderful. So. But I will show off some of my other puppets too on some of my other videos. So that's the housekeeping stuff. Again, listen, I understand this has been a lot of fun. But if the district wants us to shift to one of those 3 platforms, obviously I'm going to go with that, and we'll figure it out from there. And we still got our Google Hangout alumni. All right. So what I've done today is hopefully if you're in my class, you've downloaded this. What we're going to do is I'm just going to show you a couple questions on the kind of stuff that you might see for quantum numbers. Now, again, listen, remember, as I said before, we're in a pandemic. The assessment's going to be different than traditional assessment. If you are going to go on in science, you better start working out a little bit on your own. Okay, you need to maintain your sea legs, so to speak, for next year. The content that I can push through remotely is not going to be as close as what we could do when we were together each day. And obviously a lot of you guys have other things you're worrying about. You know, you have family members, jobs, and stuff like that. So if you only use the minimum coverage, just the video quiz and the MCs, you will put yourself at a disadvantage in the future. At some point, this pandemic is going to lift, and we need people. Obviously, I think the pandemic has shown us this, that we need people in science who are ready to handle these sort of scientific technical problems. And so, you know, it's going to have to be some independence here. And so obviously when we get to quantum numbers, there's not going to be any kind of traditional assessment, but let's look at the kind of questions you might be asked. So again, what are the 4 quantum numbers? What do each signify? And what are the rules for each? And so just based on what we learned about quantum numbers last time, remember there are 4 quantum numbers. Hopefully you downloaded the sheet, but if not, just, you know, jump in whenever you want. We have N, we have L, we have M sub L, and we have M sub S, right? And N indicates the energy level. All right, we have the energy level. L is the type of orbital, essentially. Okay. M sub L is essentially the orientation of the orbital. And again, I'm oversimplifying it, but and again, remember that M sub L means you've got orbitals of equivalent energy, and they're just kind of pointing different ways in the universe, but they're all equal energy. And then M sub S is what's called spin, which is not traditional spin, but it's more like angular momentum. Okay, so again, those are the 4 quantum numbers. Now again, they all have technical names like the principal, the azimuthal, the magnetic, and then the spin. That's sort of a jerk question to ask you one of those technical names, but they show up sometimes. Anyway, and so what are the rules? Remember that N can be any positive integer, 1, 2, 3, etc., etc. Ground state atoms don't go beyond. I see some comments in the chat about joining us. Yeah, well, I mean, there might be a way to have you guys jump in if you're still students of North Allegheny and you really want to jump into the Google Hangouts or Google Meets. I mean, it's just going to be a link. I mean, I can't stop someone sharing it with you, I guess. I don't think that would be a no-no, as long as we don't share it with people outside the district. All right, the types of orbitals, right? Remember that we talked about S as the type of orbitals. We have, again, remember, shout them out. Lucy should know these. She was in my 360 video on this. S, P, D, and F, right? Those are the ground state orbitals, right? Those are the 4 types of orbitals that can show up. So the codes for that, I'm sorry. So L, the code can be, L can be anything from 0 to whatever n minus 1 is. So don't forget, you can have, it's kind of easy to remember. Each energy level has that many types of orbitals available. So the first energy level has 1, the second has 2, the third has 3, and the fourth and beyond have 4 in the ground state. So that's pretty simple. It's just that the numbers are shifted down 1. So in the first energy level, the code is 0. In the second, it's 0 and 1, 0, 1, 2, 0, 1, 2, 3. So that's the confusing part, is that it starts at 0 and not 1. Okay? And then spin, so M sub L can be anything from negative L to L, right? With the idea meaning that if S is 0, there's only one orientation, there's only one S orbital, right? But if L is P, right, 1, then 1 can go from negative 1 to 1, which means that there's 3 orientations. X, Y, Z, there, X, Y, Z. And then again, if it's 2, right, we can have negative 2, negative 1, 0, 1, 2, which is the 5 orientations of the D. And then L equals 3 can have negative 3 to positive 3, which is 7 orientations. There are some very satisfying patterns in quantum numbers. And again, a lot of this comes back to the math of Schrodinger. So that's where that comes from. And then spin can be either spin up or spin down. So again, if you can kind of work through this pattern, and in the videos I show you somehow this, and in the videos I show you how these patterns cascade. So that's the first kind of question someone might ask you, is just sort of materialistic sort of questions about that. The second question they might ask are, let's see, how many questions do I have here? There we go. So what are the 4 orbital shapes? Right, again, remember that there are, you have S, P, kind of D, which sometimes look like clovers, and Fs, which, have a lot of different shapes. One of them looks like a jelly bean Ferris wheel. S, P, D, F. And if I remember correctly, these abbreviations come from the types of lines that certain metals gave off in bright line spectrums, if I remember correctly, sharp, diffuse, stuff like that. But you can remember as spherical, peanut, do cloverleaf and Ferris wheel? I don't know. Anyway, how many electrons will each orbital type hold? Right? Again, any orbital, this is sort of a trick question and poorly written at that, any orbital will hold 2 electrons. It doesn't matter what kind of orbital you are. S, P, D, or F, each orbital only holds 2 electrons. But the entire subshell, right, and S is 1 orbital, right, so it can hold 2 electrons, right? A P is 3 orbitals, so it can hold 6 electrons. A D is 5 orbitals, right, so it can hold 10 electrons. And then an F is 7, 1, 2, 3, 4, 5, 6, 7. It can hold 14 electrons. And again, the periodic ramifications that we'll get to in a couple days, all of this stuff is baked into the periodic table, which is pretty crazy that you haven't seen that before. Okay, so those are the kind of questions they might ask you about orbitals, right? What are the 4 shapes that you'll see in ground? And again, I keep saying ground state. Right? If you have excited electrons, you can get to higher types of orbitals, G and H. But we're not going to deal with excited electrons at this level. Our only concern in first-year chemistry is to find a home for all of the electrons in what's called the ground state, the least excited state. All right? So that's another type of question you might be asked. All right, so this is a classic question. This is probably the most common kind of question you'll see for quantum numbers. All right, they'll give you a set of quantum numbers and say, is this a legit address for an electron? All right, and so here we go. So let's look at these addresses. So what you just want to do is start at the beginning and then kind of cascade through the rules, right? Can N be 2? Yes, it can, right? If N is 2, can L be 2? And again, I will not wait for the latency delay, but no. Remember that if N is 2, then L can be anything from 0 to N minus 1. So if N is 2, this could only be 0 and 1, so 2 is no good, so we stop there. And this is the most common kind of quantum number question that you'll see. They're easy, they're fun on the final. Again, I don't even know what we're doing with finals this year, but this is a no-brainer to stick on a final, right? I could easily see a question where you have 4 of these and find the one that's not legitimate or something like that. Okay, so anyway, let's look at the second one. Can N be 4? Sure, why not? Yeah, N can be 4. N can be any positive integer technically, right? If N is 4, can L be 0? Yeah, it can. Because remember, everything starts at 0. 0 represents an s orbital, so we get all these fun little codes. Maybe not fun. But if S is 0, can M sub L be 1? No. Right? Remember that M sub L can be anything from L to negative L. Right? So that means that's really the number of equivalent energy orbitals. So in an S subshell, there is only 1 orbital, so it must have the designation of M sub L equals 0. That's the only address. M sub L1 does not start showing up until you get P orbitals, right? Because then we have 1, negative 1, 0, and 1, because again, if L equals 1, M sub L can be anything from negative 1, 0, or 1. Whoops, 1. Whoops, 1. I don't know how to erase, and I'm too lazy to look that up. So no erasing. All right, okay, and then the last one, all right? So if N equals 3, right, can L be 1? Sure can. Right? If L is 1, can M sub L be 0? Yes, M sub L can always be 0 because that's the default address of an orbital, 0, right? And then we flare it out on each side. We flare it out. There we go. Watch. Oh, no, that's not the right emote. Oh, no, that's just me flexing. There we go. So we flare it out on each side, right? Negative 1 to 1, negative 2 to 2, negative 3 to 3. Okay? But look at this. This is a no-brainer. That's like the worst electron fake ID in the world, right? M sub S equals 0. No, it can't happen, right? Yes, Derek has pointed out that, if we do a Google Meet, there will just be a link. I don't think it would be a big deal if other North Allegheny kids showed up to our meets. But again, we can't really open those up to people outside the district. So, be careful who you share that link with once we have those. Anyway, I don't see any. By the way, listen, I still want that side conversation. Let's back channel while we're going through these problems. Do you like Google Meet or do you like Blackboard Collaborate? Blackboard Collaborate seems to have more bells and whistles. But are they worth it? Are they worth it? All right. If you tried them out, please give me some feedback in the chat. All right. So let's finish these up. Right. Look at these fun quantum numbers things. This is what we'll be able to do. All right. So here's another type of question you might get. Right. What specific subshell do each of these represent? Okay. Well, remember, this is the energy level, right? And this is the orbital type. And these together give us the subshell. Right? N is the energy level or the electron shell, as you'll see the terminology, but these two together is a subshell, right? Well, again, any, I mean, I guess if it's North Allegheny alumni, I don't know. Let's see what happens with what we do next week. I know we can, yeah, and listen, side note here, yes, and Emily points out that you can record Blackboard collaboration sessions, but as I understand the intent of the North Allegheny School District, they don't want us to record any live instruction for legal reasons. And so I don't even know if we're going to be able to record them or if they're going to be able to be available for 24 hours for kids that aren't available. Those are really, really good questions that I'm going to try to find out in the in-service tomorrow. So we have that sounds fun. We have a remote in-service tomorrow. It's going to be great. And so I will try to find out if, because there are kids that have to work or help with family and they can't attend the live sessions. And so these were nice for those kids. I'm sure we'll figure it out. But those are excellent questions. And again, feel free to email, the principal and ask, and not to bug anybody, but just to say, hey, listen, what are the rules going to be for if you miss a live session and things like that? Because these are things that we have to figure out for tomorrow anyway. So I always say when you have to ask a question, ask it from sort of listen, I don't know what I'm talking about. I'm sorry if you've already answered this, but how are students going to get material if it's missed, things like that. And we're going to find all these things out. Yeah. Yes. Yeah. So, well, listen, So real quick, by the way, the term periodic table link is confusing. The next couple lessons, by the way, we'll get back to this problem in a second. After spring break, we're going to talk about orbital diagrams and electron configurations, which are easy. Once we get done with that, we're going to then hit some of the connections to the periodic table, which I called periodic table links as a video quiz, but it's not called that. The video is called periodic ramifications, and that's the confusing thing. And so that video quiz covers the next two videos. It covers the modern ramifications, which is sort of like the periodic, the links. Quantum mechanics links to the periodic table. And it was poorly, again, I apologize, those names didn't link up. And then that video quiz also covers the atomic radius video quiz. So if you just keep following video quizzes, after we get done with noble gas abbreviations, whatever the next quiz is, those two quizzes are covered on the PT and atomic radius video quiz. And then the next two videos are covered on the next video quiz. And again, I will... record that. Yeah, good question about making the live stream unlisted. I still think that even if I did an unlisted live stream, it is not following the intent of the district. They are very clear that we should not be recording live instruction after spring break. And this is technically a recording of live instruction, even though it's just live chat. And so, this was a makeshift way of getting us through the last 2 weeks. And so I want to respect the intent of the district and then consolidate what I'm doing with the district expectations, along with not recording instruction in any way. So I get that. I think the concerns about recording live instruction mainly is dealing with live video. They don't want, I think, videos of North Allegheny students being recorded and getting out there, or teachers recorded or getting out there. There's lots of reasons litigiously why this is not a good thing. And so I think that's the big concern, is just having videos of lessons that are out there, I think. I think that's why. So that's why I don't think they're allowing us to record it. All right, but anyway, but again, what do I know? I'm just a dude who teaches chemistry. So let's look at this. So N plus L right? So this is the second energy level. And then again, everybody, what's L equals 1? Remember, it goes 0, 1, 2, 3, which is S, P, D, F. So a 2 and a 1 would mean that it's the 2P subshell, right? That's one place. That's the P on the second energy level, right? All right, so 4 and 0 would again be the fourth energy level, and that's an S orbital, right? And then finally the third energy level, and then a 2 would be a D. So this would be the 3D. So what we're going to show in that modern ramifications video that I incorrectly named, I'm going to show you how quantum numbers and these actual subshell shapes defines the shape of the periodic table. It's crazy how S, P, D, and F is already baked in to the shape of the periodic table. It's really wild. All right. How many values are there for M sub L? So again, for this, there is one value for M sub L, right? There's only one orbital. For P's, there are 3 values. For D's, there are 5 values. And for F's, there are 7 values. And these, again, how many values is really how many orbitals, right? How many orbitals are in a subshell? So I'm just trying to come up with all kind of different ways to ask you the same question. And then again, order these subshells in terms of increasing energy. Well, in case of this, right, it's pretty obvious. This would be the lowest energy because it is the second energy level. This would be middle of these because it's the third. And this would be the highest because it is the fourth energy level. And again, we'll show you all about finding the energy of subshells compared to each other. Very good questions in the chat, by the way. Sound on Blackboard Collaborate has not been good. Okay, that's good. I'm gonna check. I'm gonna check both those out. Honestly, I feel like I'm leaning a little bit towards Google Meet just because it seems simpler, and I don't really know if we need like surveys and things like that. And I can switch my screen and draw on PowerPoint or something like that. So we'll see. All right, the last question that, again, people might ask, this one's a little trickier. What is the maximum number of electrons any atom that has these quantum numbers can have? Now, that's poor. That is a mouthful right there. What is the maximum number of electrons in any atom that can have these quantum numbers? That's a little wordy. I apologize. What I was trying to say is, in an atom, if n equals 3, how many electrons can be n equals 3, right? Well, let's think about this, right? On the third energy level, right, there are 3 subshells, S, P, and D, right? So how many electrons could live in the third energy level, right? 2 here, 6 here, and 10 here, right? Because again, remember, it's 1 orbital that can hold 2, 3 orbitals that can hold 6, and 5 orbitals that can hold 10. See how I'm just coming up with all kind of different ways to play with this stuff? All right, so again, that's 18 electrons. The astute student might recognize that back in your old days of remembering how many electrons were on an energy level. These are where those numbers came from. To be honest, I don't really think there's any reason for knowing how many electrons are on an energy level. It's sort of irrelevant. You'll see why in the next couple lessons. Okay? All right, so listen, if n equals 4 and L equals 2, all right, well, so we're on the fourth energy level. So that's good to know, but really it doesn't really matter that we're on the fourth energy level because all that matters is that we're in an L equals 2. All right, well, what is an L equals 2? L equals 2 means that we are in a, again, 0, 1, 2, right? So we are in a D subshell, right? So in a D subshell, right, we've got 1, 2, 3, 4, 5 orbitals because if if L equals 2, then M sub L can be -2, -1, 0, 1, 2. So 1, 2, 3, 4, 5 orbitals. So this is 10 electrons. Okay? Oops, 10 electrons. Oop. Oh, geez. I should really learn how to erase. All right. So again, these are just kind of weird ways to play with quantum numbers. Okay? All right, if n equals 2 and M sub L equals 1, all right, well, again, we're on the second energy level. That's not really all that important. Well, I guess it is. Because on the second energy level, we can only have 0 and 1 for L, which means we can only have S and P, which means that there is only one chance, 0, -1, 0, 1, right? There is only one opportunity for an M sub L equal to -1, right? If there was a D, then we could have it again, or an F. But since we only have one opportunity for an M sub L to -1, that means there's only 2 electrons that could have an M sub L of -1. Now, again, listen, this is the most advanced question. that I could probably ask you. This is kind of high level to piece all this stuff together. So I'm just showing you some of the opportunities of things you may run into. Don't freak out if you're like, well, I don't get it. But again, all I'm trying to do is just show you different goofy ways to play with the quantum number codes. So, all right. So last but not least, if n equals 1, if we're on the first energy level, again, if we're on the first energy level, that means s can only be 0. So all we have is a single s orbital with m sub l of 0, right? And so m sub s is -1/2, which means one of the electrons, again, we usually go spin up and then spin down. So only one of the electrons will have a 1/2 designation. So again, remember this was, I think this ended up being 18. Oops, you guys probably can't see that. This was 18 electrons. This was 10 if I remember correctly. This was 2 if I remember correctly. And this was 1 if I remember correctly. Yeah. So hopefully you liked those sort of high level quantum number problems. Again, when we get to the assessment for this, I don't know what we're going to do. I'm excited about sharing the modern atomic theory thing with you in an hour or so. I think you'll really like it. But we'll see what happens for this. I don't know. So anyway, so after spring break, I will, sometime during spring break, probably tomorrow or later, I'll let you know where we're going to meet. If I had to guess now, it's probably going to be Google Meet. I like it. It seems pretty simple. And so maybe clean and simple is the way to do this. And we're going to actually not be discussing quantum mechanics influence. Sorry, that's incorrect. It will not be that. Sorry, I got ahead of myself. We're going to be talking about OD, orbital diagrams, right? Which takes quantum numbers, which simplified quantum mechanics, and then it simplifies quantum numbers. So if you can draw a box, you can figure out where electrons live in an atom. I kid you not. It's super easy to do. So I think you'll like that. Everyone else, let me know what you think you'd want for this. And I think oh, okay, good. I have one more slide here. All right. So, this is it. This is our last, live terrible art improv. I did not get a chance to get good at art. I thought I was going to get a better artist at this, but, draw your classroom from memory. No, I'm not drawing celebrities. Stop asking me to draw celebrities. No, I couldn't even, Lucy, I could not even draw my desk setup from memory. Yeah. Why does everybody want me to draw Jim Carrey? I'm not a caricaturist. Stop it. No, I'm not doing, no, stop spamming the chat. Stop spamming the chat. I'm not drawing a celebrity. I don't even know. I could draw a skinny dude with a beard. No, Hunter, I said no celebrities. That means I'm not drawing you either. Yeah, I'm not drawing Hunter either. No, I'm not. No. Stop spamming the chat. Why is everybody? Hey, Jason's here. Hi, Jason. No, I keep going. Stop it. No celebrities. I'm gonna choose. It's gonna be artist choice soon. If you keep spamming the chat with telling me to draw celebrities, if I wanted to be a caricature artist, I'd be showing up at weddings and stuff. I'm not, Jason, stop drawing celebrities. How about zoo animals? I could do zoo animals. Okay, it sounds like, okay, fine. I'm going to draw zoo animals that I haven't drawn before. I will draw okay, here we go. Ready? I'll draw my favorite animal of all time. Everybody knows, of course, what's my favorite animal of all time. Anybody know? Anybody knows my favorite animal? Anybody? No, I'm not drawing any celebrities or celebrities in their own minds. Anybody? Red-tailed panda, you're correct. Nobody said that. Red-tailed pandas are the best. They are the greatest animal in the world. I don't know how I would draw that. If I ever get a chance to hang out with the red-tailed pandas at the Pittsburgh Zoo, that would be a semi-dream come true. Look how adorable red-tailed pandas are. Oh, look at you. Hello, hi, buddy. Oh, my gosh, you're adorable. Hi there. Oh, red-tailed pandas are the best. It's not a panda bear, it's a red-tailed panda or red panda. All right, another animal. Yeah, actually, this guy's name is Peanut Butter. He actually has a name. My kids have a red-tailed panda stuffed animal, and it's they called it Peanut Butter. Yes, I thought so. A raccoon. Ooh, raccoon kind of looks like a red-tailed panda. Now you're trying to show that I don't know how to draw a red-tailed panda. I appreciate that. That was kind of mean. But okay, let's draw a raccoon then. Raccoons. My God, that's okay. You're right. I don't know how to draw raccoons. I'm going to show him with his opposable thumbs. There we go. This is taking too long for our improv art today. He's hanging out. This guy's always in my garbage can, and I should be putting like a rock on my garbage can, but I kind of like raccoons. So if he's in there getting some of my leftover food, I'm okay with that. And I know that's wrong, but if I'm wrong, I don't want to be right. There you go, buddy. That looks like a cat. That's like a bad Garfield. That is a bad Garfield. That was terrible. Any other animals? A beaver. Okay. Yes, I don't know. I'll show you what a beaver looks like. Ready? Here's a beaver. Do 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 do. It's a vampire. Do 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 do. Oh my gosh, this guy is looking sickly. Oh, this guy's in bad shape. Oh no. Oh God, now I'm getting flashbacks of the hamster. There, look at that. Oh man, that's terrible. Oh, those were rough. Yeah, you guys pushed my artistic skills in this last day. I appreciate that. So listen, stay safe. Watch out your families. Don't get complacent. Yeah, that is gonna haunt my nightmares. Yeah, that. Well, that's what happens, man. You get one shot. That's it. All right. So, anyways, so I don't know who Steve is. Uh-oh. There I am. So listen, again, maybe we'll play with live streams. Let me know, comment in the chat or email me. So enjoy your spring break. And we will, see you afterwards. So, thank you for watching. Keep an eye out for my new content. If I did not answer your questions, students of mine about the class procedures, let me know. And keep an eye out. In about a half hour or 45 minutes, I will post the exciting instructions for your next individualized remote learning assessment. So to be continued. Thank you for watching. You are missed. And have a great day.